So, why we call a real number as real? Why not unreal? If you want the answer of this question, make sure you watch this video till the very end. Hi, my name is Surya, and today I am going to explain you the concept of real number, rational number, and irrational number. So, if I have to define a rational number, how I will define it? Any number which can be expressed in the form of p by q, where p and q are integers, but there is a mandatory restriction on the domain q that it can take any value, but it can never be equal to 0. So fine, let us say we take p is equal to 2 and q is equal to 3. Then our number is 2 by 3, and 2 by 3 is a rational number. Now again, if we take p as equal to 7 and q as equal to 11, our number comes as 7 by 11. Obviously, it is also a rational number. But do you remember? In my last video, I told you that 10 different numbers combine to form the rational numbers. If you have not seen that video, make sure you click on the above link and watch that video first. Okay, so can we express all those 10 different types of numbers in the form of p by q? Of course we can. And here I will do this. Right, let us say we take an even number 2. Can we express 2 in the form of p by q? Yes, we can. How? 2 is equal to 2 divided by 1, which is in the form of p by q. So obviously it is a rational number. Now let us say take any prime number. Let us say 3. And can we express 3 in the form of p by q? 3 can be written in the form of 6 by 2, which is in the form of p by q, or we can write 3 as 3 by 1, which is in the form of p by q. So go ahead, you know all the 10 numbers and try by yourself that can you express all those numbers in the form of p by q. I am very sure you will find that yes, we can express those numbers in the form of p by q. Now it is fine when we have to write in the form of p by q. But is there any mandatory requirement when we do decimal expansion of the rational numbers? Yes, there is. Suppose a number is given in the form of p by q and we are doing a decimal expansion. And there are three mandatory requirements which has to be fulfilled. Number one, the decimal expansion is an integer and the fraction part is 0. That is, we do the decimal expansion and it comes as a complete integer. For example, 6 by 2, which is equal to 3. Number 2, the decimal expansion has non-zero decimal part but which terminates after a definite point. For example, if we do 8 by 5, then it comes as 1.6. Now you can see that 1.6 exactly stops at 6 after the decimal. So this is a finite decimal expansion. And the third and the most important one, that if this decimal is non-terminating, then it must be recurring and repeating itself. For example, if we do the decimal expansion of 8 by 6, then it comes as 1.333 and this 3 will continue, right? Then how we write 8 by 6? We write it as 1.3 bar. Now this bar over 3 represents that the value of 3 keeps on repeating after the decimal, and in this way we can represent any decimal expansion of a rational number. So for one last time, let me define the rational number in a more conceptual and useful way. So a number which can be expressed in the form of p by q, where p and q are integers and q cannot take the value of 0, is called a rational number only if its decimal expansion is either absolute integer or it is terminating after a certain point. If it is non-terminating, then it must be recurring and repeating itself after certain values. So this is more conceptual and more useful definition of a rational number. Now it becomes very easy for us to define an irrational number. How? So a number which cannot be expressed in the form of p by q, and whose decimal expansion is non-terminating, non-recurring, is an irrational number. For example, the value of pi. What is the value of pi? It is 3.14596 and blah blah blah. It keeps on non-repeating but continues till infinite points. So since this value is non-repeating, non-recurring, it is an irrational number. The value of root 2, 1.41, again blah blah blah. Since it is non-repeating, non-recurring, it is irrational number. So next question is, can we express this rational number and irrational number on the number line? Of course, we all have done this. We can express any odd number, even number, prime number, fraction number, decimal number on the number line. But can we express root 7 or the value of pi on a number line? Yes, of course, we can represent it. So both the rational number and the irrational number exist on the number line. So I come to my question, why real numbers are called real? See, real numbers are made after combining rational and irrational numbers. Since irrational and rational number both can be represented on the number line, and they exist on the real number line, hence their combination is called real number. Why? Because these numbers exist in reality on the real number line. Now definitely you must be very happy because I finally gave you the answer why real numbers are called as real. But one question comes to my mind, that how to prove that an irrational number is irrational. For example, if somebody asks me to prove that root 7 is irrational, prove it. How will I prove it? Well, that's a question for our next video. So make sure you subscribe to my channel. And if you like learning with me, please give my videos a thumbs up. That's a moral boost for me, right? And make sure you share this content with your friends because sharing is caring. So I will see you in my next video. Till then, take care of yourself. Bye.